everyone. Welcome to another awesome day of FileMaker training. I'm Richard Carlton, creator of FMTrain.tv, where every day we're having great fun. We're learning about the FileMaker application and how to build great applications. The fun part of my job is I get to interact with you folks. And I mean that very seriously. It's the highlight of my day is coming on the live stream. When I don't do the live streams, I miss it. I kind of enjoy teaching and educating and things like that. We're going to jump into data modeling. If you come up the upcoming broadcast live stream, anyway, so today is going to be data modeling. Tomorrow's open Q&A. Monday is low yield nuclear weapons with the FileMaker platform. I kind of forgot what this is about. I have to go back and refigure out what we were doing for this. And then Tuesday is Jake Shealy on something about expanding grids. It's kind of a technical, interesting exercise. So that's next week. So then as a reminder, if you want to support the channel, if you can send cash for Claris, that she likes that, or you can buy one of our bundles. For these prices, you get my undying love for a year and priority access if you email RCC. Moving along back to bill of materials in data modeling. So we've talked about yesterday data modeling in terms of interrogating your customers or your people that you're building a solution for, whether you're an in-house developer or you're an outside consultant. And you have to talk to people, understand how the business works. So one of you, and did Andy bring this up originally? Or did someone else bring this up, the bomb thing up originally?
Andy brought it up originally.
Right, that's me.
That was you, and you brought it up. And then, of course, he said that he's not using FileMaker anymore. That was kind of an awkward moment. But that being said, it was a interesting question about bill of materials because it's one of the more complex things that you can do. And part of the variations of bill of materials is that how your business operates and the way it works. Now, there are pre-built bill of materials solutions out there that are quite a bit of money, right? Because we're talking about big time manufacturing, right? Like if you're going to manufacture electronic device, especially, and if you're going to build the circuit boards and things like that, the bill of materials is basically describes a product, like a widget, right? Claris is not even a good example. You need some sort of widget, but you would have a mouse. Say you're going to manufacture a mouse, okay? And so the mouse has in it a little circuit board in here, right? It also has this wire with a USB thing on it, on a plug, a USB-A plug on the end of it for the most part. It's got a little laser component in here or infrared light, however it's working. I think it's laser. And so the idea is that if you're going to manufacture and put this together, you're the actual manufacturer person, you're going to have a list of all the elements that go into the product. And so you have these parts that go into the product. There's some sort of assembly line or someone is putting these things together and they have to have all these parts that are made available. So they put them into a single package and box, right? And so the idea becomes is that you have to talk to people and find out what they need in terms of bill of materials. Most people, they call BOMs, B-O-M. And of course, people freak out when you say that. That being said, the idea is that if I started working on this file earlier, about an hour and a half ago, so we could kind of jump forward of what we learned yesterday and the day before. And if I'm on this file right here, you see bill of materials. And so it's a BOM. So the BOM is this would be like the mouse, right? The mouse, right? The completed mouse. And I haven't cross-connected the relationships that I want to show you what I did. So I interviewed myself. Hey, Richard, would you like to talk about BOMs? And so as I was discussing it with myself, I came up with the table structure. So I'm going to go file, manage database. This is the table structure that I came up with. I'm going to set subassembly apart for now, for the moment. I'm just going to set that aside. So you have essentially, and people have different terms for these, and you could even have parts that you manufacture. Like if you were just some sort of company that were doing assembly, you would buy all the parts and then assemble them together and you'd have the completed product, but you might manufacture some of the parts yourself. So what you have is you have parts that are commodity items, for the most part, like a screw. A little screw on the bottom of this thing. Are there screws on it? I think there are like 4, 5, 8, 10, 12 screws in this, on the bottom of this. The screw is a commodity item. You buy them in a bag of 100, you buy in a bag of 1,000. You're going to pay minor amounts of money generally for commodity items. Then you have items that are serialized. Like you might have a circuit board in this mouse that has a serial number attached to it. So as the company is pumping out the circuit boards, this third-party company, they serialize it, okay? So the idea is that you have serial items commodity items, we have a catalog. So what these are is that one specific screw with one specific size with one specific material. The commodity item, a catalog, is where you're going to put that screw in once. Okay, and so the serialized is the same thing. You're not going to put every individual serialized part in there, but you're going to have it as a catalog item. Okay, so you have this circuit board, it's serialized. And so what happens is that you end up trying to add it, the serial parts that are used. So in the BOM, so this is kind of that join table idea. So you have a catalog of parts that you might use, that you're going to use. You have a catalog, then they're either serialized or commodity. And so every unique item is in there. Every unique part is in there once and once only as a reference. So a catalog is a reference. Then if we're going to build the BOM kit, say I have four screws in it, I might have that screw size once in the commodity catalog, but then in the commodity parts used, I would have potentially 4 records in there. Or I would have 1 record in there with a quantity of 4. But the point is that as I build the BOM, the kit, I know that I need 4 of those screws, right? And so that is where this gets interesting. So what people like to call a join table is essentially this idea where this says commodity parts used right here and serial parts used. But really they are the stuff that people say the word join table largely because they say that when they suspect that there's a table in there they need to use because the relationships don't work correctly, but they're not sure why, so they just call it join table. But the reality is that you have a catalog of parts that are available in the warehouse, and then if you're going to build a widget like a mouse, you're going to need to put 4 screws in this mouse. Now, what's interesting, what bombs as we put this together, and this is not something we get to today necessarily, but what people say is, given the parts I have in the warehouse right now available, right? Like if you go to the catalog and you say commodity parts in here, it's a unique part, but there's a quantity that says there's 555 of them in the warehouse, and the serialized parts will say there's 100 of them in the warehouse, right? They each have different serial numbers, but there's 100 in the warehouse. How many mice can I make? And so part of what you have to be able to do is write a script that will simulate and calculate the number of mices that you can make, that the people and the manufacturing people can make, given 550 screws and 100 circuit boards. If we know that now off the top of our head, because we're all smart people, off the top of our head, if I tell you have 4 screws per mouse and you have 550 and you have 100 circuit boards, for every circuit board you need 4 screws, right? So then if you have 100 circuit boards, you can get 100 mice, and there would be 400 screws to go with it. So the limiting factor in that is a circuit board. So what these systems do is they will tell you, well, you can only make 100 with what you have, and then you could tell the system, for example, well, I need to make 2,000 because Dell just ordered a bunch of super duper amazing mice from Ed Burkle's mouse company, right? Ed Burkle makes mice, and he needs to order enough parts to support that 2,000. Right? And so that's kind of what these systems do. They figure out what you can make at the time and how many they can project in the future, how many parts you're going to need, that kind of thing, and get them ordered. So to order it, of course, you'd have to issue a PO to the company and then track the number of items that are delivered, things like that. So there are pre-canned systems to do this. You can build this in FileMaker, right? But it's not a afternoon project.
There's a question from Centauri about how does it work with self-join, but that was like at the very beginning of the chat. So I don't think that's like related to the current conversation.
You're asking what a self-join is? We'd have to look that up and decide, but you're talking about a relationship back to the same table, right? So, I mean, nothing in here right now requires what I've done to do that. But I talked to Catherine about this when we interviewed her and we helped her with her, and Margaret's talked to her a couple times. We'll probably talk to her some more. Catherine knew the business process for the most part, but then she also had learned some FileMaker parts, and so she was trying to reconcile what she knew in FileMaker with what she knew for the business side. And it's been a growing process for her to learn all these bits and pieces. She has a fairly elaborate recording, theatrical release, kind of musical sheet music kind of business she's trying to model. And it's releases and recordings and MP3s and sheet music and all this arrangements and all this other stuff. So pretty elaborate. in this, and so I'm not talking about that right now. I'm talking about the kit issue right here. So if we talk about the kit, let me just go in here real quick. So what do we decide? So I built the tables out. I built some keys out. At this moment, I built this. This is as far as we got. This is mostly what we've been doing the last couple of days. So now we're going to extend beyond this. And so what I'm going to be is I'm going to say, okay, I'm going to be on this layout right here where we have the bill of materials. So this would be, if we call it Super MOUSE, 55. So it's Ed Burkle's Super Mouse 55, okay? You'd have some sort of SKU number, right, that's in there. And then you'd have a description. It's a mouse that everyone loves. It's so amazing, right? And so the idea is that you let the layout, your needs of the layout drive your relational graph, knowing that you're going to do Anchor-Buoy. And so what happens, you go to layout mode, you're going to say, well, I need to see a portal of all the parts that I need to put in the product. Well, there's two sets of parts in the product. You have serialized parts and you have commodity parts. And so what I'm going to do is I'm going to come over here and I realize I'm going to put a serial portal over here and I don't have any relationship. So I'm going to have to cancel that. I'm going to go into manage database. And I use a keyboard shortcut. So it's the shift key, and then it's the shift and command and D, or shift control D if you're on Windows. And so I'm on a layout that talks to the T1 right here, layout for this. And so I need to put some other relationships in here. I need to see the commodity parts, right? Or the serialized parts. So I'm going to add a table, and it says add a table, but we're not really adding a table. That should say we discuss this add table occurrence. I'm going to go to the commodity parts used. Okay, I've added it right there. It's over here. I'm going to move it out of the way right here. I'm going to attach the ID bomb primary to the ID bomb foreign. I already, because yesterday we talked about primary keys and foreign keys. I already did these before we got here today so we could move forward in the conversation. So we have that like this. I would rename it to be T1A so we have some sort of plan, right? Once again, there are some spaces in here. I'm not terribly concerned about that at the moment. And then what I'm going to do is, just for simplicity at this time, I'm going to move these out of the way to the right. I'm going to make my little yellow box bigger here. And then I'm going to make this a little bigger, and then I'm going to put it up here. And then I'm going to double click here because I wanted to allow it for the time being to allow the creation of related records. So I've got that one right here. I'm going to move that up there. And now I'm going to, I could take this one and duplicate it. Let me duplicate it and roll it down. So the rub is that I like this name. It kind of helped me a little bit, but I really need the serialized parts used. And as soon as you click that, it wipes it out down here at the bottom. You're like, oh, that sucks. So sometimes you'll want to copy the name before you do that. So there's T1B underscore parts used, okay? And so now we have both of these, and I'm going to put the primary and the foreign key here. They're both in here. And so you can already see that we have two children. There's the parent, two children on the relationship graph using an Anchor-Buoy design. So when we come to a layout for here, it doesn't have to evaluate all these other connections, which there will be a bunch here. It's only going to evaluate for the moment these two. We say, okay. I come over here, I want to put the relationship on. Then Margaret, once I drop these on, we're going to be looking for questions. And I can make this a little bigger, but for now, we say commodity parts used. I say, okay, 4 rows. And we just say commodity parts used, primary key. And the catalog, if we want for now, let me see, come over here, make it larger. That would be more useful. Okay, we got that one. And then essentially what we do is we would do this again. I'm going to come down here and do it again for the parts used, okay? Makes sense? Parts used, serialized parts used. Same kind of deal, okay. And then you're going to put in the serial part primary key and that one right there. So that's B. That one's B. So I got that field and that field right there. I want them like that with the label on top. Drag them over here. So that loosely gets us going along the lines of what we're looking for. So in these, you'd be able to list the parts that you wanted. And of course, these aren't in here correctly. I mean, move them out, let go, and then move them back in. And now they're in the portal. Nope, it still didn't do it. Oh, the reason it's not showing up is I don't have the checkbox to turn on created related records automatically turned on. So I'm going to go File, Manage Database, back over this one right here. It was checked off. See that? If I go to this one right here, not checked off, that allows us to see into there and to allow us to click in here and to create the related record, right? Makes sense? From this point, we have this basic structure. The next thing to do is to be able to add data in here. New
The
window.
questions we have are more like related to like basic questions about data modeling, so not necessarily about this specifically.
Which table would be the main axis or the axis of the other? Okay. I know Power Eagle was here the last couple days. I'm thinking, yeah, that because the conversation we spent the last 3 days, we interview the customer, we built the structure, and then we start to structure the layouts, and the layouts drive what we put in the Anchor-Buoy. So real quick, Power Eagle, so that we covered this kind of a little bit yesterday to a point. So let me pop this, make it fit page width. So if you build a relationship graph that looks like this, you're going to have a serious problem, right? Once again, you have this spider graph that kind of looks like this. The problem with this design is that the way FileMaker works is if you're on a layout, every layout is attached to a table occurrence. These are table occurrences. They're not the actual table, the base tables underneath this. A base table might be have 5 or 10 table occurrences on the graph, okay? So you have a layout that's attached to this. For FileMaker to render the layout, it has to actually evaluate every item that's connected to that table occurrence. So designing a graph where everything connects in the center is going to lead you to performance hell. It's not going to be very fast. It will slow down. And so what you want to do is that, like over here, this was one of the ones we were looking at the other day, and this is the perspective of us on the layout. FileMaker has to evaluate literally almost 100 little boxes on here, and that takes time. Yeah, Andy, what's your question?
Does it query everything or just the ones on the layout? Because I've had kind of like the spider web, because it's what I'm used from SQL or SQL, and it worked quite well.
No,
wasn't in production mode at that time, but
it worked well. Okay, so back up. So worked well and worked slowly. So let me quantify those terminology. So FileMaker has to evaluate the relationships to display the layout. Okay, it will not necessarily run all the associated calculations within here. It'll only evaluate the calculations that are on the layout. That being said, what happens is that people will build a solution, and it works great with you on your local computer. So what ends up happening is that as you add more users and you add thousands and thousands of records, if not millions of records, it has to evaluate all that. And what you'll notice is a substantial slowdown in the product because you've designed it. The spider diagram specifically, Hansa, who's from 24U, did time testing on it and determined that this diagram right here was one of the worst ones you could possibly use because it forced it to evaluate all this. The idea is that it's going to evaluate all this. If you come down here, and there's another one, right? But you come down here, all it has to do is evaluate the items that are connected. It won't evaluate everything else. I have senior engineers. I have senior engineers who refuse to have relationships that go beyond about 4 or 5 deep maximum because the performance drop off is so much. And so it's kind of a limitation of the product. This design methodology here will be much, much faster than this one. This one, people come to us, they complain about the performance, and we see this, and it's basically kind of a redesign, rebuild of the file when this happens, because you really have to, you can't have it evaluate everything, but that's what it does. So if you have it working successfully well with something that looks like this, then as you add records to it and you add users and you have it on a server and you're accessing it across the internet, the performance will drop off. Normally people see a pretty good drop off when they hit about 30 users and quite a few records, like say 100,000 plus records. Those seem to be common numbers we see where it drops off. So whereas if you design it over here, we've really never had it drop off performance-wise. We had 415 users banging away on one system with 17 million records in it, and the only way to get it to fall over was everyone ran a sub-summary report at the same time. And even then, it didn't crash. It just slowed down to the point where we thought it crashed. But that's a pretty big difference. Claris has a CRM file where they did some things in it that, in fact, if you do a search for FileMaker CRM, one of the top hits you'll get is Claris's internal solution. That solution does things like this, does other things that are not great, and it will fall over at 10,000 records. That's it, 10,000 records, and it becomes unusable. And so the goal with what we do and what I explain to people is to try to make sure that they design in such a way that they're not going to hit an arbitrary bottleneck. If you hit a bottleneck with what we're doing, you've hit the end of what the platform can do, right? So that's kind of the idea with that. It's a good question. Photograph of relationships that you show us on the screen, the disorder would be more advisable to start from scratch to update it. What you need to do is, here's the underlying guidance on this, and because part of this conversation is not so much me saying this is bad, okay? Just from the standpoint of understanding, let's pretend for a moment that this design methodology that you see right here is the fastest possible design, okay? As a person who documents and supports the solution, can you tell me what this guy is going to see if he bounces all the way through here and around over here? Okay, can you tell me what that relationship looks like? And so from the standpoint of supporting the solution and documenting it, even if this was high performance, which it's not, this also is very difficult to support because it's hard for you to, in your head, understand the logical permutations of what that data will look like if you can jump through 12 different relationships, right? I mean, I know some smart people, and I'm sure Andy's much smarter than I am. That being said, Andy's brain is going to overheat and start melting if he tries to internalize all this in his head at one time. So
I don't even try to.
Yeah, exactly. So this is so part of this down here, this methodology, A, it's faster. B, it's easier to follow. So what are the rules for this? The rule is that the layout attaches here. And then as you need to do things on the layout, like I want to see this data. I want to see this data. Do you have business reasons to see the data? Totally cool. Then you start dropping things on the layout. Oh, I can't drop that on the layout unless I put a relationship. So then you add the relationship here. So your needs in the layout drive your decision-making on the relational diagram. Catherine, who is Centauri, asked me this question many times about 2 months ago. What is the logical order of building a solution? Most people would assume you define the tables, define the fields, build the relational diagram, and then after you're done, you build the layouts. And really what you need to do is understand what the tables are, get the tables kind of structured, put the basic TOs on the graph like over here, and then as you build the layout, then start building your layouts, and as the layouts need things, that will inform you is a term that will educate you or guide you as to what relationships you need to add to support that. And so you might end up with one with 2 or 3 on here. You might end up one with 100 on here. That would be a lot, but 20 or 30 is not uncommon. I've had some that have 20 or 30 on there, and could be a little slow. Now over here, the question is, should you rebuild it or start from scratch? What you could do is basically you have to look at the layout and see what it needs and then remove the things it doesn't need. The problem is that other things need this. It's almost like you'd want to come down here and build, you could leave the spider in here, but build a new, like put this down at the bottom, grab that and stick it down at the bottom and attach the layout to that and then reconnect the pieces you need. This is a lot of work. Let's just be clear, it's a lot of work. You spent a lot of time the first time building it. And this happens in systems all the time, Andy, I'm sure seeing this, where you build something, it organically grows, it becomes kind of unwieldy. And then someone says, well, we really should rebuild this and redesign it because we've learned so much that if we rebuilt it again, we would be much smarter and it would be better and more understandable and less trashy and junky inside, right? That happens. And so it's going to be a lot of work. It's not a quick conversation. Schmiegel says if it's 20 or 30 connections, but each connection is only one record, for example, would that be pretty fast? Yeah, I mean, so here's the idea. Okay, so here is my jar, right? Everyone ready for the jar? Remember the jar? Okay, this is Mark Richmond's example. Okay, you have a layout. Okay, and there's nothing on the layout. How hard is it to calculate? I have empty hand. It's easy. Couple fields. I got a couple coins. It doesn't matter what the coins are. They could all be the same coin. Doesn't matter what currency. That's not the point. Then you add 20 fields onto it. Okay, so now I got 20 fields. It's a little heavier here, right? Follow this? Let me make myself a little bigger so we can have this moment here, okay? Because this is very intuitive once you understand all this, right? So here's your coins right here. They're kind of heavy. Not too bad yet. Oh, well, this isn't so bad. Okay, so your FileMaker server does this for you. Now you're going to add an unstored calculation to the layout. Okay, here's another one. And now you're going to add 2 hidden objects to the layout. So that's 2 more calculations. So 1, 2. And then you're going to add like 15 or 20 extra TOs that you don't really need. So that's like another big pile of at least 1 coin for each one of those, right? So now it's starting to get kind of heavy. And this is for 1 user, okay? Then you put it up on the server on the internet, so the latency goes down, right? So now it's you've got the same number of coins, but it's trying to pour them. You know, I have this. If I had a tube like this big long tube, and you poured them in here, and this is your pipe in your office. But if you move the internet, you're going to have a garden hose, something smaller, right? So then you have to pour the coins to that little tiny hose. Then you add 5 people to this. And the FileMaker server, to support those 5 people at the same time, it's going to have to do this much, okay? And then you add 1 million records on top of it, and then suddenly your processing looks like this. So you went from, oh, it's only one little thing, okay? And I'm not picking on Schmiegel in any way, but this is Mark Richmond's demo. It helps. It's cumulative. It's cumulative, right? They talk about radiation, like don't go near a radioactive thing. It can hurt your body. And some people, you know, they talk about, well, it's a cumulative effect. If you get that toxic stuff near you, that's a little bit's okay. But if you keep getting it, it accumulates within you and causes problems. This right here is this thing on screen right here with 300 people accessing it across the internet with 5 million records. This is some heavy. Okay, so are we clear kind of the analogy on that? So every time you drop a coin in, it's only a coin. Just as a developer, just think about that. It's 1 coin times 20 people or 100 people times however many little bounces in here that go on. Now, as life goes on, we add more records and more data and bigger databases. Back in the day, the biggest table size you could have was 32 megabytes. 32 megabytes of data in a single table. And then every table, you could have 20 or 30 tables, right? Or you're like 32 megabytes. I got PDFs that are bigger than that, right? So Claris gives us more performance, and then we demand more of the product, and the world moves on. Wait till AI comes into stuff, and AI's in there doing whatever it does. Sooner or later, someone will figure out how to put AI into FileMaker. Looking forward to that. Nick's talked about that a little bit, but Nick had to beat the AI with a stick to get it to perform correctly. So it's not that anything's wrong. It's FileMaker software, and it does a lot. And if you ask it to do a lot, then it's going to do a lot. But if, like, say you have a bunch of coins, but you only have 1 record, well, then you've got 10 coins and you can throw them around. It's no big deal, Schmiegel. I think you just have to be thoughtful about, you know, how many hoops you have to have it jump through, right? How many hoops, how many coins in the jar at one time? Because if you spread the jar out over a day, like one person logs in, there's never more than 2 or 3 people using a solution. Well, there's 50 people who use it, but they're around the world and they're on different time zones. So you never have more than 5 or 6 people using it at one time. Cumulative during the day, 50 or 60 people. Is that a problem? Probably not, because you're spreading it out. But if all 50 or 60 people hit it at one time, they run a big report with all those coins, there's going to be some spinning beach balls or progress bars. It's not a FileMaker issue. Other systems have the same problem. There've been stories about Oracle being thrown out of projects before, because not that Oracle was slow, but the developer who built the code for the solution didn't do it in a way that would scale and the performance was good. So it's nothing like having a $200 or $300 million project that gets blown up because it doesn't go very fast.
In SQL, there's actually something called the N+1 query problem. So which says that if you do a select on, so you have cars and you have wheels, and if you query all wheels from a specific car and you select that car in this query, then for every car it's gonna check all wheels, and you have n+1 queries, so the application performance goes pretty down. So I think it's kind of like the same problem in FileMaker, but if they would specify that out, you can, at least from Claris' side, you could say, no, it's on you.
Yeah,
So,
no, the Claris has always been hesitant, and I used to have conversations with the previous CEO, and they were always nervous about talking about performance because things were always situational. Like they could do testing and find it was twice as fast or something like that, but then someone would have a solution that looked like this spider diagram that you see on the screen here, and it wouldn't be twice as fast. It might not be, it might be 10% faster, and they didn't want to get yelled at for making promises about performance when things are so situational, right? Between everyone here has made custom solutions, and no one's solutions are identical. There might be some that, like we saw yesterday, who was a gentleman? It was
Dimok.
And we saw his solution yesterday, and he took kind of a nick solution or a starting point solution, but he's added and changed quite a bit in there. He's done a great job. He kicked good job, but his is different than yours, and it's different than mine. They're all different. So yeah.
About the bill of materials again. So there's one thing I was stuck at.
Okay.
And I don't think there will be enough time to do that in FileMaker, but maybe to talk just about it. Now, the thing you have implemented was just one bill of material has n parts.
Okay.
And serialized and n commodity parts.
Okay.
But now when there is a commodity part, which again has a bill of material, this is going to be used in the parent bill of material one. You know what I mean?
So you're saying that a commodity part has its own components to it? Is that what you're saying?
For example, or a serialized part. That could be as well.
Well, that's the idea. I put in here as a sub-assembly, right? So the sub-assembly is kind of like a bomb, a junior bomb, whatever you want to call it, but it would have its own supporting parts that it uses, and then you would roll that up. So you're talking about multiple levels. So I don't know how. I mean, it would have to talk to the customer, whoever we're building this for, and figure out how elaborate they get with manufacturing, right? I mean, imagine
making deep, actually. So for my customer I'm working, it's n level deeps. So can be 3 in one product, can be 20 in the next product.
Okay.
And I was looking for a solution in FileMaker to have everything in the most parent bill of material to show all the children bill of materials in one layout. I was able to click into the child bill of material to then have again the child bill of material, but I couldn't get all the sub bill of materials into the most parent one, if that's
no, you
not
can.
too confusing.
I totally understand. So what he's saying is that he would want to. He went like, so I have a sub assembly, and I'm gonna take these two over here, and I'm gonna try to throw this together visually, but I'm not going to actually connect everything. So let's pretend that these two are over here, right? And they're connected right to the subassembly. Then what he would want to do is have a subassembly here that connects to that. And then down below here, these items are actually subassemblies. That's what you're saying, in number, right?
Yeah,
so yeah, the idea is kind of visually building it so a subassembly could reference a previous assembly. Yeah, you'd have to figure out. So here's the deal. You're rapidly heading towards building a spider diagram over here, wherever that would be, that document that we had, the spider, because this would get really ugly potentially.
You wouldn't do it like that.
And you're referencing itself. You're referencing itself. I would be inclined, between you and me, because you have such an elaborate, because basically you could have it say, I'm just going to put this back down here. Say that a bomb references another bomb, right?
Yeah.
And so it references the other bombs, and then those reference other bombs. So you have this corkscrewing kind of deal. I would script it. I would write it with scripts. And so it wouldn't evaluate it Like that's the whole idea with the spider diagram. You go to layout and all these connections there, it's going to do a bunch of evaluating, right? Claris can optimize that, make that go faster. At the end of the day, if you have 100 connections in there, it's going to have to look at 100 different things. How deep it goes is up to Claris to decide that. They could make it faster, but obviously 5 connections is going to be better than 100 connections, which is my point about the spider diagram. With this, you have a kind of a self-referencing kind of almost like a recursion kind of deal where it's self-referencing itself. I would be inclined to write a script that performs the find, that gets those records, and it builds it out in an unrelated display in a list view that's unrelated. Does that make sense? So you could code it. You don't have to code it in FileMaker. You could code it anything. But I'm saying instead of trying to get the relationships to do it for you automatically, was in the car with Margaret last night, and it's probably what we're going to dive into tomorrow again as another part of this conversation, is understanding that trying to get the relationships to do all the magic for you is a faulty premise. It's kind of what Nick will do a lot of times. People who are really smart in the world of FileMaker will try to create these crazy relationships that will do this stuff. And the idea is that if you're not as bright as they are, like me, but you still need a reliable way of building high performance solutions without trying to have 8 or 10 relationships that are Cartesian join here, but a greater than here, and this kind of thing, and an auto enter, and it'll trigger. Instead of that, you build the basic relationship to display, and you have a script that will run. You can even have the script run on the server where it builds out maybe data in a list view that's unrelated. Right? It builds out that data for you. It pre-builds it for you so you can reference it without having all the relationships, right? So you build it all with scripts.
So basically just print out text.
It's basically a big block of text. I would build it into a display table, but that's the way I would do it because, and you're like, well, that might be really slow. Well, then maybe FileMaker is not the best tool. And of course, that's what Andy found out, is that for his specific situation, it might not be the best tool for him. I think FileMaker gets better. The idea is that you can overwhelm FileMaker by having the relationships get really crazy, shall we say. And I think that I'd want to do it with scripts. So for example, I'm going to just do one example right here, and I'm going to show this to everyone. And you've seen this solution before, but I'm going to talk about this from an interesting standpoint. So I'm going to bring up this BVA solution because we ran into this here, and we were trying to beat our heads against the wall about how to solve a problem. And so let me just bring this up real quick. So this is that helicopter thing when you see me over there, they're working on this or using this, or we're flying the whatever we're doing. And you come over here to work orders, and you have these discrepancies. Discrepancy doesn't matter. It's an item. It's something that they fix on the aircraft, okay? Doesn't matter what kind of aircraft. And so what happens is that this is a portal. So this is related items. But if you want to add a new discrepancy, you could always just add one at the bottom. How hard is that, right? So if I come over here to I'll come over here to this one right here. So here is 76 Papa Echo, okay? And we add a new record. So you say, well, it'll run a script and it'll just add it to the bottom. Now you could scroll to the bottom and see like an open, a auto enter, auto enter a new record, right? You have the empty portal spot at the bottom. You could do that. But then I say, well, what if I want to insert a discrepancy? Insert it. When I say insert, it inserts it in here between these two, between that line and this line. Well, how do you do that? And of course, a lot of FileMaker developers get into this mode where they're trying to figure out how to concoct a relational diagram that will support this. And if you're Josh Ormond or Wim DeCourt or Chris Moyer or Todd Geist, I am not any of those people. I'm a normal human, okay? Or Nick Hunter. He's one of those people too. For me, that's a bridge too far. I don't want to have to depend upon being a Nick Hunter to be successful in the world of FileMaker. So what do? I don't do any relationship stuff to make this happen at all. This is just a script that says, I'm on this line right here, I'm gonna pop a new window over here on where it's not through a relationship, but pop it natively on the data entry or list view for that table. I'm going to create a new record. I'm going to set some stuff in there. Then I'm going to close it and come back here and refresh. So if I say insert discrepancy, oh, I have to hold it's a safety. So people don't click it by accident. I'm going to hold the modifier key down. I'm going to hold the safety down. It runs it on the server. So it ran the script on the server because it was too slow on the client. It came back and did a refresh. I don't know how to do that through a fancy relationship. You probably can, but once again, I'm not Nick Hunter or Todd Geist. Okay, these people that are brilliant. Heidi Porter, brilliant people. I'm not one of them. I'm a normal human. So I use a script because what did the script say? How hard is this script? Think about this. Catherine in Power Eagle could write this script. Okay, copy this number over here, right there. Copy that number so we know what it is. Come up here to this and copy the primary key for this work order, which is W0136 right here, right? Then go to wherever layout where these records are natively in the record, right? As a parent, create a new record, paste in the not copy paste, but use a set field with a variable, but I'm going to say paste in the work order number, then paste in that number plus 1. Commit record, close the window, come back over here, refresh object. That's it. I think there's a couple more things to it, but it's pretty simple English. Go forward, turn right, turn left, turn right, wave up and down. It's basic steps like you're teaching a robot to walk around the floor. Go 4 steps forward, right, go to the left, go to the front, copy, paste, stand up, sit down, right? Basic stuff. But look at the sophistication which you could build. Go ahead, Andy.
I have a professor. He always says, make it work, make it fast, make it beautiful. And that's 100% the case.
Yeah, and the rub is that I'm not dependent upon some crazy relationship magic to make it work. And this is the other day. So Larry the Marine is here, and I'm gonna kind of end with this unless we have some other questions. Larry the Marine was here, and he had a consultation with one of my junior engineers, and the junior engineer was trying to figure out how to solve a very basic problem in my mind with sort of fancy relationships, and they couldn't get there. But I built the fix for Larry in 15 minutes, and then made a training video on it, which I'm going to make available to all of you, which took another hour. The video was the hard part. And all you have to do is understand that, step away from the relationship graph, keep it simple, write a script, go here, copy this, paste it in here. And in the case with Larry, I just had it on a loop. Yeah. So Larry's happy. Larry the Marine's happy with the demo file I built. So yeah, so that's the whole idea, is trying to figure out how to guide all of you to success. But all of you understand that I'm actually out rooting for you, want you to be successful. I really do. At the bottom of my heart, I want all of you to be wildly successful in what you do. And anything I can do to help with that, I'm happy to do. So that's it for today. Andy, I want to thank you. Rick Fosnot, Media Sandbox, you folks are awesome. Labo 44, thank you. I will catch all of you tomorrow. Hasta. Got a report of an individual up here who may be a FileMaker license. Well, it's potentially expired. Look at the back of that car right there. Looks like the FileMaker license has expired. Sir, I need you to step out of the vehicle. Sir, step out of the vehicle. Sir.